Today we are going to discuss some IITG questions like previous class. So here I taken the questions from the previous year's IITG in the topic of moving laws of motion. So in this question, what is given? You can see the question on the board. So two masses each of mass m lying on the x-axis at position minus a comma 0 and plus a comma 0 respectively, as shown in the figure. You can see the figure here, and they are connected by a light string, and a force is applied at the origin along the vertical direction. Vertical direction. As a resultant, the masses move towards each other and without losing the contact with the ground. What is the acceleration of each mass? Assume that instantaneous position of the masses as minus x comma 0 and x comma 0. This is the question which is given in IITG 2004 question where we will discuss now. So what is the question here? First, they taken two masses here, separated by certain distance here, right? So in this case, this is the origin. If we say from the origin, the distance of that one initially at a position, that means if we say here, I'm taking this one is A, is the initial position of this one from the origin. Now what we are doing when they are at this position, the positions of this one is given as minus a comma 0 initially, this is plus a comma 0. Clear? Now this is negative x-axis, if we say this is positive x-axis according to given diagram. What we are doing along this direction, we are applying the force. If you apply the force, what happens? This is the string actually. These two masses, this is the mass m, this is also mass m. These two are connected by a string. I am drawing in a red color light. This is the string which is connected, negligible mass. So this string we are pulling in this direction. If you are pulling that string in this direction with the force of F, what happens? These two masses moves towards each other like this. They try to move towards each other because string is moving upwards. How the string moves? This way the string is going to move upwards. Whenever we are pulling the string try to move upwards. So what is the acceleration of this mass body we are asking to find? So to understand this one, there is a position in the question very clearly given. Assume that instantaneous position of the masses are minus x comma 0 and x comma 0, means the actual initial separation is a comma a, but when you are solving the problem, they are asking to take the position of the two masses from the origin is minus x comma, that means this position is equal to minus x comma 0 and this position is plus x comma 0 from the origin. So that means in this case already we apply the force on the string, and due to the applying the force on the string, what happened? The string is going to be modified like this. This is the way the string moves. Understanding? So in this case, what I can say here, before whenever you taken this string length, this string length is how much A. So whenever it is pulled by force of F, the string length A, this is becomes A and this also becomes C. Now here what I am discussing here, force. Because they are asking to calculate the acceleration. Acceleration means whenever you are pulling the string like this, these mass bodies are going to accelerate towards each other like this. They are asking to find this A value. So second diagram. At this instant of position, they are asking to calculate. So in this case, very clearly you can see this string makes a certain angle theta, with this both the sides. So we are getting a two triangles here. One in the one triangle, in this case the side of this one is equal to, I can take it as one triangle. You can say the side of this one is equal to what I can take. This is nothing but I can take it as x minus this is nothing but length x, then into x-axis direction. This is also length x. And this is the length A, already we know that, m theta. And this length we don't know that, this length we don't know that. If we require, we will calculate that, right? So what we need to calculate acceleration, what direction the acceleration is along x-axis. So to find that one, first, what makes this body to move? Which one is making this body to move? In this case, you have to understand very clearly. The string is pulling. That means whenever you are applying the force like this, what happens? The strings, will be tension will be created in the strings. What will be created? Tension will be created in the strings. When the tension is created in the string, that tension we can resolve in the component. Means this is the two bodies are taken here, and this is a string which is connected like. When you apply the force on this one, this is the way the string is going to moves. That means this is the direction of the tension will be there, right? So this tension is make an angle theta here, both the cases. What you do is, now you take the vector component. Tension is a vector having angle direction. I am taking like this. Here also tension I am taking like this, and this is the direction of the force which you apply. So according to geometry, I can tell that this is making an angle theta. Now, if you resolve this t into components, we are getting two components. One component is called, this is t sin theta component you get, and second component in the direction of this, which direction in the direction of the force, we are getting one component that is nothing but t sin theta component you get. Similarly, another end also, okay, for the components you get, one component you get that is t sin theta, because that is also tension t, okay, negligible, and another component we are going to get along the direction of the force, that is also t, okay, cos theta. So here I have written down here, just to check it, this one, this is not t sin theta, this is t cos theta. One component is t cos theta, one component is t sin theta. This is t sin theta, this is t cos theta, this is t sin theta, this is t cos theta. So here our concentration is, this is moving towards each other with the acceleration e. So which is causing the acceleration? This t sin theta is causing the acceleration. Understand? Because it is acting along the line of motion of that body. So I can write here simply, I can take the concept here, force acting on a mass body is due to t sin theta component. Right? So what is force? Force equal to mass into acceleration is equal to t sin theta. This we can write. Right? Now in this case they are asking to find the acceleration. Acceleration is equal to nothing but t by m into sin theta we can write. So this is the acceleration of the mass body. But if you see the options, okay, here if you see the option, one option is given 2f by m into under root of a square minus x square by x form. This all options are in the form of that. That means here sin theta is there. For sin theta we have to replace it required, okay, notation. To find it, that one, what I am doing here is, okay, to find the t value not given in the answers, only f and m values given. So you have to remove the t values. What are the two values? So you have to replace t value and sin theta value. So how to find this t value from the diagram? If you see this t value here, okay, the t value you have to write it in the form of t. Sorry, f. So how to write it? If you look at the diagram, this is one of the t cos theta, this is t cos theta. These are the two t cos theta are acting upward direction along the direction of the force. So from that I can write force is equal to nothing but 2t cos theta. Now from this I can find the t value. What is t value? T value is equal to, that is nothing but f by 2 by cos theta. F by 2 cos theta I can write. Now put this t value in this equation. Next we need sin theta. So first put the value, okay, that one in this equation, so that what the equation you are going to get, you can check it. So if you put the value in that, so what I can write here, acceleration a is equal to nothing but, in the place of t, what I can write, t by, that is 2m into, right, because already we have m here, and this is numerator we have sin theta, denominator we have here cos theta. So what is sin theta by cos theta? Nothing but tan theta. So that is nothing but f by 2m into cos theta, okay, sorry, sin theta by cos theta is equal to what I can write, that is I can write as tan theta. So here tan theta value we need to find. Which value? Tan theta, because in the options we are not having tan theta. So tension is eliminated, but again theta value is there. But tan theta value you can calculate using this triangle. So in the diagram already we discussed, in the triangle this is nothing but x value, and this is nothing but theta, and this is nothing but a value. So from the triangle, what is tan theta? Tan theta always becomes opposite by adjacent. Which is opposite? This is opposite. What is adjacent? This is y is the adjacent of this. So from this I can write a is equal to nothing but f by 2m into tan theta value is equal to what I can write, that is nothing but x by y. So anyway, x value already, according to the given question, x is given, but y value is not represented in our option, so we have to modify that one into known terms. So what is y value? According to, if you see the triangle using Pythagoras theorem, y value is equal to what I can write, under root of a square minus x square we can write, because a square is equal to y square plus x square, so y square is equal to a square minus x square. So what is y value? Under root of a square minus x square. Put that value. So that means f by 2m into Okay, that is x by, what is y value? Y value is equal to under root of, that is a square minus x square. This is the acceleration of the mass body which are moving towards each other whenever the two system of mass body come to the string, whenever you are pulling with a certain force. Okay, so if you see the options, look at all the options. 2 by m into under root of a square means x square by x, 2 by m into, okay, x by under root of a square means x square, like that options. If you observe the answer, what form it is looking like, it is by 2 into x square by under root of x square minus a square. That means this is the correct answer for your question. This is asked in the year of 2004. This is the model only, just to understand how we are solving the question. Next question, if you see what is given in this question, block on block like, okay, connected body system like question. It is only understanding of the concept how to do it. Two blocks A and B. This is the block A, this is the block B. So both are having same mass. Mass of both the blocks are same. And both are moving on the horizontal surface. Two horizontal forces F and F are applied on the block C. This is the one of the force we applied here, F. This is another force to F. As you are looking, both are acting in opposite direction, as shown in the figure, right? The block A does not slide on B. That means this A which is there, which, okay, when you are applying here, forces are not same. So one dominating others. So there will be a chance of sliding. Okay, so here they are saying that block A does not slide on the B. So A is not sliding. Then the normal reaction acting between the two blocks is they are asking to calculate. Answers in terms of given like this. In this case, our concentration has to be, okay, so come across the case of this one, two forces are acting and two masses are there. So there is a net force acting on the body. So what is the net force? Net force is equal to nothing but 2F minus F. That is equal to F. So what is the acceleration of system? Acceleration of system is equal to force by mass. That is net force by mass. So what is net force here? F only by M. So acceleration of the system is equal to F by M. So they are asking to calculate normal reaction, right? So acceleration if they are asking, you can find it using this. In this case, what direction this net force is going to act? Which is more? F is more than F. So the net force always acts towards the left side direction. This is the net force value, that is F, because 2F minus F. Now if you see this one, they are asking normal reaction. Where the normal reaction acts? Normal reaction is one of the contact force. It always acts along the contact between the two surfaces. This is the contact between the two surfaces. Yes or no? So it is always acts normal to the surface. Means you take a line which makes an angle 90 degrees. This line is called as normal. So this is the direction normal reaction is going to have. This value they are asking to find. To find the normal reaction value. So we know only force here. What direction the force is acting? Towards left. That means B block applying the force on the, okay, B block is applying the force on the A block in this direction as F. So whenever it is applying the force, at the same time the other body also has to apply equal and opposite, then only the reaction takes place. So according to that one, so there is a force is going to act on the B block by the A block is F, black color one, right? So in this case, our requirement is this. Okay, using this F value, we need to find the M value. Now, if you see the geometrically, now how much angle this is? Okay, the line of contact between A and B making an angle 30 degrees to the surface, horizontal, right? So, according to geometry, I can take it as this is 30 means opposite angle also same. This is also 30. I can take this, and here the angle between the normal and the surface is 90. 90 minus this 30 if you taken, what the remaining angle you are going to get? This angle you are going to get as 60. So normal reaction is a vector quantity which is making angle 60. So resolve this sum into components. If you resolve this sum into components, that means this is a line I am taking free body diagram like I am taking here. So this is a normal if you say, this is a horizontal if you say, it is making an angle 60 degrees if you say, this normal if you resolve into components, you are going to get M cos 60, one component will get, and this direction already there is a force acting on the B block. So we need to calculate M value. So in this case, net force already over. Using this net force, it is accelerating. That's why I can write simply here M cos 60. Okay, M cos 60. What direction it is moving? Towards left. So this force is more than this. Like this, we can take M cos 60 minus F is equal to nothing but we can write as mass into acceleration. This mass body is going to accelerate. We need to calculate n value. So in this case, n, okay, cos 60. What is the cos 60 value? Okay, cos 60 value is equal to nothing but root 3 by, okay, 1 by 2, right? Cos 60 value is 1 by 2, we can write as 1 by 2 minus f is equal to mass into acceleration. Where is acceleration? We can write as already f by m. So otherwise you keep it like this. So n value we need to find. N is equal to what I can write, that is ma plus f, right? Ma plus f, that is by 2. If you multiply with 2, that becomes, okay, 2 ma plus f. First, this is a part we get. Now if you see the answers, what were the answers are given? The normal reaction given in terms of f only. F by 2, f by root 3, okay, root 3 and 3f. So I can write this, okay, answer in terms of only f. So that means ma is equal to as force, because force equal to ma, you know the basic formula. So I come to that one. So what I can write here, 2 times of f plus f, that is equal to nothing but 3f is the answer for this question. So in this, the normal reaction is going to act how much? 3f. Next model question, if you see what that question is given. Based on connected bodies and rotation motion, as well as, okay, you're applying friction concept, rotation motion and dynamics. Okay, so in this case, two block masses, small and capital M is given, are connected by a cord or passing through the frictionless pulley. So this you see this one, this is M, small m, this capital M, both are connected by strings as you are looking here, and this is connected to one of the pulley. Okay, and this both system, understanding, which rotates about the vertical axis with an angular velocity omega. That means these two are, we are rotating about okay, axis. This is nothing but we taken as axis, around it is rotating with omega. So you can see the diagram again in short way to explanation. Two masses given, and these two masses are rotating about this axis with angular velocity omega. Now what the angular velocity we are asking to find? If the coefficient of friction between the two masses, that means here whatever the masses which are present here, okay, this surface is not the smooth surface, it is a friction surface. Okay, so that's why there is a coefficient of friction is there. The coefficient of friction between the small m and surface is mu1. Here it is mu2. That is given respectively. Determine the value of omega at which the block starts sliding radially. That means they are asking to find the omega, what the minimum, okay, rotational angular frequency is required or angular velocity is required so that this can be start sliding radially. Radial means along the radius. Means if you see this one, both are going to be rotated in a circle. Okay, if you see the circle, it is they are going to rotate in a circle. The circle generated by small m is equal given as r1. The circle generated by capital M is given as r2. That means if you come across here, so this m, small m, if it is rotating about this axis, it creates a circle of, okay, rotation of radius r1. If it is rotating about this axis, if you say like this, and it creates a radius of, okay, rotation, that is r2. This is the diagram is given. Now what they are asking, radial, okay, angular velocity minimum required so that it can slide. That means when they are just ready to slide, so there is a friction is going to happen, because when there is a relative motion between the two contact surface, then friction exists. So when they are not, when they are at rest, there is no friction will be there. So here if you see the diagram, M1 and M2 are not ideal. They are connected internally with the string. If you see the diagram, here it is connected with the string, right? Here I have taken one of the pulley here, and with this there is a connection of string, and there is connection of string using pulley. Now if you are taken the, okay, free body diagram for this one, and what you can say, if you taken the free body diagram for this one, so in the free body diagram it is clearly indicates that you can indicate the direction of the forces. Along the string there is a tension is going to act, this is the direction of the tensions. Yes or no? Along the string always we have a tension. So here it is the pulley and this is a string, so here also there is a tension, so we can write that T. So small and capital M both are connected with the same string, that's why tension throughout the string is same, and also they did not mention the mass of that, that's why massless string concept, the tension anywhere along the string is same. So in this case what I can say, M1 is rotating in the radius of R1, M2 is rotating in the radius of R2. Our concept of understanding is whenever any body is rotating, okay, there is a rotation concept will be there. So here one body, that is small m, So when it is rotating, what are the forces are acting on this? One, rotation concept, there is a centrifugal force is going to act. Centrifugal force, outward force, because when it is rotating, what happens? There is a force is going to act outward direction, that is called centrifugal force. Centrifugal force in terms of mass, and in terms of angular velocity, you can write m into okay, that is mr omega square is a form like that, right? Yes or no? Mr omega square. What is r here? Radius. What radius the m1 small m is rotating? That is r1. So m r1 omega square. Now when it is trying to move like this, okay, this is the one of the centrifugal force. If you take in the case of big body, that means large block, that is capital M. Mass of this one is capital M. So in this case, it is also experiences a centrifugal force, that is also m r2 omega square. The concept is involved here in this both are not having same mass. You know that centrifugal force depends on the mass, radius as well as angular velocity. So anyway, both masses are moving with the same system. That's why angular velocity is same for the both. But what is difference? Radius is different, mass is different. So which will experience a more centrifugal force? Means the second one, that means this the big block having more mass, it experiences more centrifugal force. That's why when it is experiencing centrifugal force to outward direction, understanding exactly opposite direction of that one along the contact surface, frictional force is going to act. That friction we are taking as F2. Understand? And not only that one, this M is already connected with a string. Okay, here there is a pulley system. You can see resulting. Okay, string is connected. There is a tension also acting here. So there are certain forces we can take here. That means big block experiencing the centrifugal force outward direction, and towards the center, towards axis, tension and friction force is going to act. Similarly, for the block small m. So if you see this one, okay, in this diagram, if this is moving, because centrifugal force experienced by capital M is more than small m. So this capital M is trying to move outward. When it is trying to move outward, what happens? The small one is going to move towards axis. Because mass is less, compared to the capital M, it experiences less centrifugal force, that's why it moves towards axis. So in this case, I can say when it is moving towards this direction, when it is trying to move towards this direction, what happens? Friction is going to generate in opposite direction, because friction is one of the opposing force. So in this direction, there is a friction going to act between the contact surface of the small m and the surface, that is F1. So next, the small m also connected with the string. Look at this one, this is a string which is connected. The tension of the string is anyway T. So that means here also I can take here, this is the direction of the tension which is going to act on the small. So using the free ball diagram concept, I can able to identify the forces here. First, our concept is which experiences the most centrifugal force. Capital M is, that means more mass block experiences more centrifugal force. So this block making the small m, okay, a small m in motion, because both are internally connected. So capital M is moving towards right side direction, so small m will move towards left side direction, because they are connected with the massless spring along with rotation. Now from the free body diagram 1, from the free body diagram 2, now we can write the equations here to find the angular velocity of the rotation. So first using the first small m. So what is the free body diagram? From the free body diagram I can write it. So what is the net force direction? Net force direction is towards right side direction. That means I can write as I will write as m r1 mr1 omega square plus what is the friction F1 is equal to tension T. Both are equal and opposite. But because the question is asking what is the minimum angular velocity required, so that they just ready to move in the radial direction, just ready to move. That means they are not moving. So just ready to move means but must be equal. If it is any one value is more, then that direction that body is going to move. So that's why I am putting here. Second free body diagram, from that also I can write as second free body diagram, the mass is capital M, right? The mass is capital M. The mass is capital M. Radius is r2 omega square. mr omega square, that is mr2 omega square, and is equal to, right? If you see that one, only one is acting towards right, remaining is to this side. This side is T plus F2 is acting. Now our requirement is to calculate omega, we can write in many forms because they given in the question mu1, mu2 is given, coefficient of friction is given, friction is not given. So you know that friction formula in terms of coefficient of friction, F1 is equal to, that is mu1 into, that is the friction between small n and surface, so that is nothing but mu1, okay, mu1 into m into g. Okay. Similarly, F2, what is F2? Friction between the capital M and the surface, that is F2 is equal to, I can write as mu2 into mg. I can write. Substitute these two values in this equation, and if you want to solve it before, okay, what I will do is for less, okay, complication, just what we do is eliminate the T value, because what is same in the both, tension is same, because we've taken the tension into consideration. So to cancel the tension, what we do is subtract both. From 1 minus 2, if you do it, this becomes minus, this becomes minus, this becomes minus. So this minus will get, okay, that becomes 0. So I can write here, what the equation I can write, n r1 omega square minus capital M r2 omega square, and this also becomes minus f1 is equal to, T2 becomes 0, that becomes minus f2. This is the way I can write the equation of this after subtracting. Now substitute the values of that one, what you are going to get. You substitute the values of remaining, everything is mathematical approach only. If you substitute the values, what will write here? So I can write, what I can write here, m r1 omega square minus m r2 omega square is equal to minus f1, make that side become plus, so that means f1 minus f2 becomes f1 minus f2. Now substitute the values of f1, f2 in this, so m, not m1, that is m r1 omega square minus capital M r2 omega square is equal to, what is common here? Okay, this is, there is no common terms here, both are different masses only. Okay, thing is I can take it as g common. If you take g common, first one is m, okay, so we mu into m you get, that is nothing but mu1 into m you get minus capital M into mu2 into capital M I can write. So here also you can modify, this is not the small m, in the case of second body is big body whose mass is capital M. Right? So now we require omega. So take the omega common from this equation. If you take an omega common from this, so what is omega square? Omega square, take it common, that is m r1 minus capital M r2 is equal to g into, what I can write here, we can't take any common here, mu1 m minus mu2 into capital M I can write. So omega square is equal to, what I can write here, omega square is equal to, that is nothing but g into mu1 small m minus mu2 capital M by remaining term is small m r1, okay, minus capital M r2. So to get the omega value, omega is equal to root, okay, if it is when that side becomes under root of g into mu1 m minus mu2 capital M by, that is m r1 minus capital M r2. This is the way you have to solve the equation of angular velocity. If the question column is given in this way, you can solve it. Okay. So in this case, g is constant and mu1 is, they will give the value, small m capital M you have to identify which is more, which is less, and remaining is according to centrifugal force equation. So this is the way you have to solve the some part of equation. So this is the angular velocity of given system of masses which are rotating about an axis. In this next question, if you see what is given here, a block of mass 5 kg moves along the x direction, subject to a force F equal to minus 20 x plus 10 newtons, and with the value of x in meters and at time t equal to 0 seconds, it is at rest x equal to 1 meter. The position and momentum of the block at time t equal to pi by 4 seconds they are asking. Two questions are there. Here a few options to see. Distance is given as well as momentum is given. So they are asking the position x equal to how much? That is the first question. And the second question they are asking to find the momentum of this block mass n. Okay, at what time? They're asking at the time of t is equal to nothing but 5 by 4 seconds. So if we see the question, the force which is given here is a variable force. F is equal to minus 20x plus 10 newtons. As x value changes, automatically force value changes. Suppose if x equal to 0 if you taken, we put the x value 0, initial position if is taken, at that moment minus 20 plus 10 becomes, okay, that is x value 0 if you taken, this total becomes 0 and plus 10, that means force value becomes positive. Suppose in the question if you see this one, it is at rest position at x equal to 1 meter is given. That means if you take an x value is equal to 1, so what we are going to get, f is equal to minus 20 into 1 plus 10. How much you are going to get? That is nothing but minus 10 you are going to get. Minus 10 means what direction it is? Negative x direction. So the block is going to move in the direction of negative x axis. That is the thing we need to understand under the application of this force. Whenever the force is acting at the position of x equal to 1, so the block is trying to move towards the negative x axis at time t equal to 0. So after the time t is equal to, okay, after the time t is equal to pi by 4 seconds, they are asking to find at this position what is the displacement. Okay, what is the displacement? That is one question, and second one is what is the momentum at this position. These are the two parameters of questions they are asking to find. So to solve this one, first what you will do? First take the force formula. Because they are given it very clearly, F is equal to how much? That is nothing but minus 20x plus 10 in terms of newtons. And you know that here at what position x equal to 1. If you put it that, it is going to get minus f, right? So here you know that f is equal to ma, mass into acceleration, because in the answers to get the velocity we require to know the acceleration. So that's why I'm converting this one into, okay, ma, f equal to ma, and x value also we are finding according to that one because time is given. Velocity time relation in terms of acceleration. So ma is equal to I can write as minus 20x plus 10. We can write. Now what is the acceleration from this? Okay, find the acceleration here. A is equal to, what I can write, A is equal to minus 20x plus 10 total divided by, that is mass of this. What is the mass of the body is given? If you see the question, mass of the body is given as 5 kg. So substitute that 5 value here. So A is equal to minus 20 into, okay, x plus 10 by 5. If you solve this one, what is the acceleration? Acceleration is equal to minus 4x plus 2. This is the called as equation number 1. So we got the acceleration, right? So from this acceleration, I can get the velocity using integration method. Using integration method, that you have to know that. So acceleration equation we got, that is equal to, how much we got? That is minus 4x plus 2. Acceleration A is equal to minus 4x plus 2 we got. And you know that acceleration is equal to dv by dt, that is dv by dt is equal to minus 4x plus 2. But here we are not having time function, here we have time function. So what we do is dv by dt multiply and divide with dx by dx here. Okay, that is equal to minus 4x plus 2 will get. Now in this case I can write this dx by, okay, dt I can write as velocity, that means I can write v into dv by dx is equal to, I can write as minus 4x plus 2. Now cross multiply here, that is v into dv is equal to, what the equation I can write, that is minus 4x plus 2 into dx I can write. Now integrate both the sides. If you integrate both the sides, we'll get the required answer for question. So here integration of this one, from where to where you have to integrate here. Starting, it is starting from rest x equal to 1, means if you see the question here, so it is starting from rest here at x equal to 1. So you are taking that velocity of this one is equal to, take it as 0, like from, okay, 0 to some v value. That means here lower limit of velocity is taken as 0 and upper limit is taken as v. And position x equal to 1 to, we don't know that where it is moving, up to x distance we are finding, so take it as up to x. So using this limit we can able to solve the value of v. So now this is remaining this mathematical part. For the mathematical part, integral v dv is equal to, that is v square by 2 that is equal to v square by 2 will get, and after that if you integrate this one, so I can write minus, that is integral 4x into dx. That I'm writing here 4x into dx. How much you are going to get? 4x square by 2 will get, and in this case lower limit is 1, upper limit is x, plus integral 2 dx equal to x, that is 2 into x is the value, lower limit is 1, upper limit is x. If you solve this one, what you are going to get, v square by 2 is equal to nothing but this is 2 terms cancel. So remaining is, that is nothing but minus x square, minus of minus becomes plus 1. So next value put 1, that is you are going to get plus 1, and this plus, this is becomes 2x minus 2 you are going to get. And if you solve this, what you are going to get equation this one, that is nothing but x square. Okay, this if you solve it, what you are going to get here, that is nothing but x square. This is minus 2 plus 1 becomes minus 1. So this equation you can write as 2x minus x square minus 1. So this is v square by 2 we are going to get. Here if you check it one small, okay, your what one, and here what the value of this one, 2x square, no? So if you put the x value 1, how much you are going to get? 2. Here we written, okay, 1, it is not 1, that is you take as 2. Because this is 2x square. 2x square value, if you put the x value, that is nothing but you are going to get, okay, that is nothing but you are going to get 2x square here. 2 is also is there. 2x square you are going to get minus 2x square, and plus minus of minus become plus. In the place of x you have to write 1, that means it becomes 2. Minus 2x square plus 2 plus 2x minus 2 we are going to get. So if you solve this one, plus 2 minus 2 get cancelled. So this equation we can write as, what way we can write? This equation we can write as minus 2x square, okay, minus 2x square plus 2x. This is the equation. Now cross multiply the 2 here. If you cross multiply the 2, so what we can get, v square is equal to nothing but, so that is nothing but minus 4x square plus 4x. So v is equal to, under root of, you will get that 4 if you take in common, that becomes minus 2, and under root of remaining is what I can take, that is x square, okay, minus x here. So check that one. If you take in this one, minus, if you take in common here, if you take in common, again if you multiply answer, you will get the same thing. That means I have taken the minus 4 common like that from the root, and it becomes like. So here v is equal to get this equation. Now our requirement, okay, is for the first question, position, finding the position at time t equal to that, right? So from this equation, if you see this one, they're asking the question of displacement, right? Velocity I can write in terms of displacement. What way? You know that velocity is equal to dx by dt. Assignment. So dx by dt is equal to minus 2 into under root of x square minus x cubed. So now this I can write in terms of like this. This is nothing but, okay, dx by this x term, bring it in the denominator of dx, that is becomes x square minus x is equal to minus 2 into dt I can write. Now integrate both the sides. Now integrate both the sides. From where to where? From x equal to 1 to x value, and the time also, and time t equal to 0 to time t is equal to from where? Pi by 4, because according to given question. So if you solve this one, what we are going to get? This mathematical approach you have to follow. If you solve this one, here integrate this in the form of, okay, inverse function of sine, we can write integral of dx by under root of x square minus 1, we can write as sine inverse dx minus 1. We will refer the books of maths in this. So lower limit is x equal to 1, final x equal to, sorry, x equal to 1 to x equal to, okay, x up to that limit of this one. Okay, x equal to 1 to x equal to x is equal to minus 2 into time. Where the time integral dt is equal to t, so the t is also limit from 0 to pi by 4. that is 5 by 4. Solve this. Before solving this one, that you are going to get this one, that is minus 2 into t value is equal to 5 by 4. I can write that is cancelled. So how much you are going to get? This answer over as 5 by 2 minus. This is sine inverse of which one? Sine inverse of that x value. If you put it, how much you are going to get? That is 2x. Okay, so minus 1. Right? From x equal to 1 to x. So inverse function multiplication becomes 1. That means here 2x minus 1 from x equal to 1 to x is equal to, okay, you are going to get 1. Right? So if you solve this one, how much you are going to get? 2x minus 1. Okay, x equal to 1 to x equal to, I can write as that is 2x minus 1 minus, okay, that is 2. Minus of minus plus becomes and 1. And this value is equal to how much? That is equal to 1. If you solve this one, plus 1 minus 1 cancel. In this case, take it properly, this is the bound here, 2x minus 1. If you put the x value is equal to this 2 minus 1, 1 you are going to get. Right, this value unnecessarily written extra here. So we have the value 2x minus 1, x value after putting x value x, 2x minus 1 minus, after putting x value 1, 2 minus 1 is 1, that is minus or minus become plus 1 is equal to 1. This plus 1 minus 1 get cancelled. If you cancel this one, 2x equal to how much you are going to get? 1. X equal to 1 by 2, that is equal to nothing but 0.5 meters. This is the position you will get after time t is equal to what time? That is after time t is equal to 5 by 4 according to the given question. Now we got the first answer, that is x equal to 0.5 meters. What the another question they are asking? The another question they are asking, if you check it that, for the another next question they are asking momentum, mass into velocity. So already we have a velocity value, I think, right? So where is the velocity value? Velocity value is in terms of x we have here. Look at this one, right? This equation you can take it, or next equation also you can take it. So we take this equation. If you take this equation, so what is the x value? V square by 2 is equal to, what is that? X value v square by 2 is equal to minus 2x square plus x. So what is the velocity of that position? Put the value of this. That means v square by 2 is equal to minus 2 into, okay, that is 1 by 2 whole square, nothing but 1 by 4 I can write, plus 2 into, right, plus 2 into 1 by 2. So if you solve this one, people that cancel, this is 2 1 by 2. So v square is equal to, if you cross multiply the 2 value, that is 2 into, again you will get 1 by 2, okay, plus 1 will get. So again multiply inside, what you are going to get? If you multiply inside, v square is equal to, the 2 to cancel, minus 1, yes or no, 2 into, that is 2, minus 1 plus 2. Minus 1 plus 2 means this is 2 to cancel, right? So 2 to cancel, that is minus 1, and here 2 into 1 is 2. So v square is equal to how much you got? That is equal to 1. So v is equal to 1 meter per second. So velocity how much we got? Velocity 1 meter per second. So what is the second question? This is the first question already over. Second question is they are asking momentum, mass into velocity is called momentum. How much mass? 5 kg into 1. That is equal to nothing but 5 kg. Okay, velocity unit is meter second minus 1. So this is the answer for your question. You can solve it using integration method. This procedure is important for the mains and advanced level questions. In the next video, we are going to discuss the more problems in this topic. Okay, so like this one topic, we will go for the remaining of the previous year's questions as well as some important concept of derivation for the mains and advanced we will discuss.